Let's now take a look at the resource recovery process. SANSHIN's resource center system is used to collect metals, chemicals, water, and energy disposed of at each line to realize resource recycling with a centralized individual recovery process. Plating wastewater-related accidents became more frequent as the Japanese domestic industry expanded during a period of high economic growth. The Water Pollution Control Law was enforced in July 1971 in order to strengthen wastewater regulations. As a result of this, SANSHIN's existing research involving industrial experiments on plating wastewater treatment for the recycling of both chemicals and water was designated as the Ministry of International Trade and Industry's Important Technological Development Issues in fiscal year 1971. Through this research, the concept of regeneration utilizing our announced cartridge-type ion exchanger led to the completion of the portable Patrone system, resulting in the development of a closed system for the subsequent plating process and establishment of the Resource Center. In April 1976, we established the Resource Center at our Inuyama factory and began sales of the cylinder-type ion exchanger, Patrone I, and launched our regeneration business. At the Resource Center, cylinder-type ion exchangers are periodically collected from plating plants, and heavy metals are classified by type to enable recycling as precious metal raw materials. Furthermore, cylinder-type ion exchangers are cleaned and regenerated before being returned to customers again to allow repeated use. We regenerate over 6,000 cylinder-type ion exchangers for our customers throughout Japan each year, and to date have regenerated over 180,000 exchangers in total. Beginning with the Tokai Chemical Industry Association Award in 1983, we have been recognized as an outstanding business in the fields of resources and environment and environmental load, and have since been honored with a variety of awards, such as the 2007 Aichi Environment Award Silver Prize for our Resource Center system. In April 2010, we received fiscal year 2009 Pioneering and Efficient Recycle Business certification from Aichi Prefecture, and also started a high-functionality resource recovery system business. And in 2012, we received awards such as President Prize of the Japan Environmental Management Association for Industry at Resources Recycling Technology System Award Ceremony. With our chromic acid recovery system, we were able to concentrate and purify chromic acid elution to acceptable resource recycling reference values, and also developed a system whereby nickel and copper that were previously converted to sludge and recycled at the smelting plant could be recovered and recycled as metal foil with roll-type electrodeposition equipment in our Resource Center. Through this, we were able to achieve improvements in resource recovery efficiency and reduce waste. Let's now take a look at the flow of our Resource Center system business. Our cylinder-type ion exchanger, Patrone I, is filled with ion exchange resin to suit the application and is then installed in the final rinse tank. By circulating rinse water, heavy metals adhere to the ion exchange resin. By continuing with circulation, the ion exchange resin becomes saturated, preventing the required water quality from being obtained. Saturated cylinder-type ion exchangers are taken to the resource center, where the cylinders are cleaned and ion exchange resin is regenerated. Cylinder-type ion exchangers collected from customers are classified according to application and the process at which they are used, and are then transferred to the regeneration process still filled with ion exchange resin. At the regeneration process, adhering heavy metals are separated from saturated ion exchange resin using regenerant. Elution containing heavy metals is then transferred to the resource recovery process. A performance inspection of ion exchange resin is conducted on regenerated cylinder-type ion exchangers before returning them to customers to be reused. SANSHIN's regeneration business employs an individual regeneration system to ensure that ion exchange resin does not become mixed with that of other customers. With the mixed regeneration systems employed by other companies, resin becomes mixed with that of other customers and is regenerated altogether, creating a risk of good resin being mixed with degraded resin or contaminated with impurities. At SANSHIN, the condition of customers' resin, the frequency of regeneration, and the level of degradation are all managed with individual regeneration. Understanding the condition of our customers' resin allows SANSHIN to notify our customers when resin has to be next regenerated or replaced. This system ensures use of resin with peace of mind. Resource recovery of effluent containing heavy metals generated at the regeneration process is carried out for each metal. Here we will look at copper and nickel recovery. The pH of all separated and recovered elution is adjusted, and then the elution is collected as metal with roll-type electrodeposition equipment. The collected metal is of extremely high purity and is transported to the refinery where it is reused as raw material. Elution containing chromium is concentrated with our chromic acid recovery system and is then transported to the refinery as high concentration chromic acid where it is reused as raw material. Through our resource center system business, SANSHIN contributes to the recycling of over 500,000 tons of water resources and valuable metals on a global scale annually, and supports the stable operation of our customers' processes and promotes sustained quality improvements.